Hi, this tutorial is part of my data science and analytics series called R to Python or R and Python. The philosophy behind this series is to help those of you who either knows R or Python and wants to quickly transition to the other one, and even for those who just want to learn both R and Python at the same time. Please refer to my previous videos from the series and topics that are already covered, and subscribe to my channel for upcoming videos. In this tutorial, I am going to demonstrate how to use both Python and R native functions to filter, subset, and use conditional filtering techniques. So let's get started. Okay, this time I'm going to start with Python. I have already created a Python notebook here. So first things first, I'm going to import the required libraries, OS and pandas, and let's look at, let's see what is the working directory here, and it is the desktop. So we don't need to change the working directory, so although let's run it, no problem with that. So let's see if it has changed. Obviously it is, and then let's load the iris CSV data. So you can refer to my previous video how I have created the iris CSV file, so you can look at that. So let's load this. Now let's switch over to R and try and replicate these commands. As usual, get wd would get you the current directory, which is again the desktop. I don't need to set it up again, so let's run it. With this, we'll be loading the iris data. You can see here the iris data has been loaded. Let's see in R, if you want to know how many rows of data iris has, you can look at it from here, 150 observations, but n row would also give you the same number. Alright, so how do you get this number in Python? So the command is len. So if you do len and the data frame, you get the number, so 150 again. So iris has been loaded in the okay. So let's look at the index of the file, the data frame. Okay, so let's look at the index of iris in Python. So the command is iris.index. So here's a little difference from R. It starts with 0, and you can see it goes all the way up to 149. Although the length says 150, so it starts with 0 and 159. What is the command in R? So so the way you can see the index is through this command, row.names. So you see it starts with 1. That's the difference I talked about. It starts from 1 all the way until 150. Alright, so how do you know what are the column names? You can click in here, you can see the column names, but if the column names are so many, it would not fit in here. And if you want to see it here in the console, the command is names on iris, names and the data frame. So you see the names here. Okay, so how do you see the column names in Python? Let's switch back to Python, and this is the command iris.names. So U stands for Unicode. So this is the column names, as you can see in here, and it's a list. Okay, so now let's create a new data frame, call it petal_iris, and only with the third and fourth index of the iris. Okay, so let's run this. Let's see how does it look. We'll return the head of the So it has petal length and petal width. So third and fourth. Let's try and replicate this in R. So the way we replicate this is we can call it out like this: petal name and petal width. Let's run this. Okay. To view this, we can either click in here or we can do head. So you can see petal length and petal width, the same data frame. Okay. So what type of R object is petal underscore iris is? So you use the plus command. So it's a data frame, as you can see in here. Let's switch to Python. Let's see, how do you get to know? The command is type, not class. So equivalent to class is type. So it's a pandas data frame. Okay. So let's do a copy of iris and create a copy of iris. So to create a copy of iris, you just have to do the data frame dot copy within parentheses. It will copy everything to this new data frame. Alright. And in the copied data frame, we want to change the name of the columns. So how we change the name of the columns is do data frame dot columns, and within this square bracket you provide the name. Just be mindful about this zero. We would look at it when we go to R. So it has 6 columns, including the index. So let's run this, and then take a look. How does it look? So this is how it looks like now. It has created the 0 columns as the index, and then all the column names got changed. Okay, so let's try and replicate this in R. So first, copying is, you don't have to do copying command. You just do iris copy, and then to just copy on its own with this with this assignment operator. And then to change the name is very easy. Names, and within that you provide the data frame name and the C concatenation with the names that you want to change it to. So let's run this, and then let's return the head of this data frame. So you see it has changed to ABCDE. Okay, so if you want to see only the last 2 columns of this dataset and their first 5 rows, so you do head and the data frame name, and within parentheses this has 2 parts. The first part before this comma is the row index, and then after this is the column index. So this essentially returns the 4th and 5th columns with all the rows, but this head operator or the head function is only going to return the first 5. Right, so 4th and 5th column is D and E, and as I said, only the first couple of rows. An alternative approach to this is going to be, you can call out the name of the columns unless rather than the column index. So it's going to do the same thing. So let's run this. So the output is going to be the same. Alright, let's try and replicate this in Python. So this is how you look at it. So 3rd and 4th becomes 4th and 5th because of the 0 index. So iris copies the data frame name, and within double square bracket, the second part inside that square bracket stands for the column, and then in the end the head is going to return the first 5 rows. So there you go. An alternative approach is almost similar as we did in R. You can call out the name of the columns here as well. So Alright, so the other way you can sort of look at the head of a particular column is in this way. So the data frame name dot the column name and the head. So this is very, as I said, this is very Pythonic. You cannot really do the same way in R. Okay. So now suppose if you want to know what is the index number of column E, right? So the index that we specify here, and if you have a large data set, you just know the name of the variable, but you don't know the index number of that particular column. So this is the command. So data frame name dot columns, and then get underscore lock probably stands for get location of the particular column. So let's read this, and it says it is on the 5th. The index number is 5, right? So let's see how you can replicate this command in R. R doesn't have a get lock function, but you can make it up in this way. So which is a very handy function, which and the column names and the arrays where it is equals to that E. So it should read me 5. So you made the same function in R. That is very easy in Python otherwise. Alright, so let's now we'll switch back to iris, the original database, and then summarize different columns. There's a handy command in R called summary. Let's run this. Okay, so this essentially gives you by variable there is basic statistics. So it's a summary statistics, right? So it has mean, first quartile, second quartile, which is the median, and mean. The mean means minimum and the maximum, and then first quartile, median, third quartile, and so on. And for the categorical variable, it gives you the count. Alright, so how do you get a summary like this in Python? Okay, so let's go back to Python. The command is describe. The function is describe. So data frame dot describe in parenthesis is going to return the count as well, and there are a couple of more, the standard deviations, as you can see here. Anything else other than this? I don't think so. Count. No, it has the count and the standard deviation as an extra bonus. Okay. Alright, so now let's get into some conditional filtering. So if you want to know if you want to construct this condition supple and greater than 5.8, I picked a 5.8 from here, so anything more than the mean, just for this example. So if you run this, it is going to return with the boolean of the index. So you get to know where the condition satisfies or not. Not very much helpful here, but if you output this, if you use this condition as to subset arrays for some and construct a different data frame, this is going to help you. So here we are going to create a new data frame, call it big supple, and inside this we are basically subsetting using the square bracket and then the condition. Alright, so it has run, and then let's see how many records do you see here in this big supple. So you see 70. This is very similar way you can replicate this in R. Let's switch back to R and let's see. So this is again, this line of command is going to just give you the index. So let's run this as we have seen in the beginning, as we have seen in Python. And this one is again creating the big supple data frame. Here, just a very minute difference is this comma. So you are using this condition to subset on the rows, and you have to return all the columns here. Okay, this is the only difference in the command. So big circle data frame has been created, as you can see in here, and it has 70 observations, which matches with the Python. Let's even view that here. So you can see in here. All right. Okay, so if we want to do a bit of more conditional formatting, two criteria here. So sepal length greater than 5.8 and petal length greater than 4.8. So let's do that, which is the big sepal. I'm calling it big sepal and petal. So let's run this, and it has created this data frame which has 46 observations. Let's look at it. Okay. All right. So let's try and replicate this in Python. There are very minute differences here. When you want to pass two conditions like this, you have to pass it using this parenthesis, right? And of course, as I mentioned, that you don't need to provide that extra comma here, because Python it should just work. Let's look at the number of records. Right, it is 46, and if you want to see this data frame, you can see it here as well. Okay, there you go. I hope that this is helpful for you if you are already familiar with R functions or Python functions, and you want to transition from R to Python or Python or R. Okay, thank you for watching.